Okay, so today we're going to begin learning. We're going to start with the review chapter. Now, notice we're not starting with section 1 of the review chapter. However, you do have the entire review chapter available to you in the module. So you should read through R1 and R2. It's basic information. We're not going to test you on it. I guess it talks about different absolute value. It talks about different types of numbers. So you can read through R1, R2. You won't be tested on it, but it's good prior knowledge that you should know maybe when you go to take the PSAT or the SAT. So the first thing we're going to talk about today are the rules for exponents. The first rule is the product rule. And what the product rule states is when you multiply powers of like bases, you keep the bases the same and you add the exponents. So for example, here is two things. It's got an A and it's got an X example. So I have A to the M times A to the N. Notice the bases are the same. So when I'm multiplying two numbers that have the same base, I add their exponents. Same thing if the base were a number. So let's say my base was a 2 and it was raised to the third power and I wanted to multiply 2 to the fourth power. I don't multiply the bases will stay the same, but then I take the exponents and I add them. Now, let's say you blank out and you're like, oh, what do I do with those exponents? Do I add them? Do I subtract them? One thing you could always do is expand this. 2 to the third means you write 2 3 times. 2 to the fourth means you write 2 4 times. And then now notice, if you were to count how many 2's you have 7 of them. Now, make sure you read directions. If it says to leave it in exponential form, this would be your answer. If it says to simplify or evaluate, you would have to figure out what 2 times 2 times 2 times 2 times 2 times 2 is. 7 times. All right, now the next rule is the power rule, or power to a power. So whenever you have a power that's raised to a power, we're going to take those exponents and we're going to multiply them. So here are two examples. If I have a to the m and I'm raising that entire thing to the n power, I'm going to take the two exponents, the m and the n, and multiply them. Here is an example with numbers where I have 6 to the second power and I'm raising the whole thing to the fourth power. So again, I would take the two exponents and multiply them and I get 6 to the 8th. Again, if you think about it logically and you were to expand this, 6 squared is really 6 times 6, and then you still have the fourth power. So then if you were to take that and write it out 4 times, so 6 times 6, 6 times 6, 6 times 6, and then 6 times 6. Notice if you go back and count how many 6's you have 1, 2, 3, 4, 5, 6, 7, 8, 6 to the 8th power. So again, think about what you've learned from exponents and you could always bring it out like that. The next one is to raise a product to a power. So you're going to be multiplying two things and that product is raised to a power. So basically what's happening here is this power is going to distribute to both of the numbers that are being multiplied. So for example, I have an x and a y raised to the second power. Notice the 2 goes to the x and it goes to the y. Now, it's the same thing if I have a constant. So let's say it's 2x and it's raised to the third power. This power of 3 is going to go on the 2 and it's also going to go on the x. So then this one would simplify. I would figure out 2 times 2 times 2, which is 8, and then the x to the third would stay. And the last power rule is the quotient. So to raise a quotient to a power, you raise the numerator and the denominator to that power. So again, remember, the operation that's understood with a fraction is division. So again, I'm going to take this power of m, and it's going to go on the a, and it's also going to go to the b, and it's simplified here. Always remember that the denominator of your fraction can never be 0. So this is this little exclusion here. If b equals 0, this fraction is undefined because we can't divide something by 0. Okay, here's an example with numbers. You would take the 4, it goes to the 2, and to the 3. So if I were to ask you to expand this, we could do 2 times 2 times 2 times 2, and then 3 4 times. If it asks you to evaluate, 2 times 2 is 4, times 2 is 8, times 2 is 16. And then for the denominator, 3 times 3, 9, times 3, 27, times 3, 81. Now, also you could think of this as writing 2/3 times 2/3 times 2/3 times 2/3. And you still will get the same fraction. But if it asks you to leave it in exponential form, you would just leave it as 2 to the 4th over 3 to the 4th. Everybody good on the rules for exponents? Let's try a few examples. So when it says to simplify, we're going to go ahead and simplify. We're actually going to, on some of these, we'll evaluate. We're just going to leave them in exponential form. So for the first one, notice we are multiplying two variables that are the same. So we have the same base. So all we're going to do is take those exponents and add them. So 4 plus 7, and I get x to the 11th power. And again, if you forget, expand this. X to the 4th is x times x times x. X to the 7th, you would write x 7 times. And now you could go back and count how many x's you just wrote down, and you would see that there are 11. Now, when you're multiplying, I guess, terms that have coefficients, we are going to multiply the coefficients, and the coefficients are the numbers that are in front of a variable. So we'll multiply those coefficients together, and then notice I have variables, and they're the same base, and I would add those exponents. So I'm going to multiply 6 times 9 times 2, and I get 108. And then for the variables, they're all the same variable. They're all x. So now I'll add 5 plus 3 plus 2, and I get x to the 10th power. The next one is applying that second power rule, the power to the power. So for this one, all I'm going to do is take these two exponents and multiply them. So it becomes 5 to the 6th power. The next one, again, this is the product. Oh, I got to go to the next slide. Okay, now again, if I go back to this one, 5 to the 3rd power raised to the 2nd power. Again, if you think about it, it's 5 to the 3rd. You would write it 2 times. And again, if you wanted to expand it, 5 to the 3rd, you write 5 3 times. And then again, you could simplify it. Now, if it said to evaluate, we would actually have to multiply that out. But we're going to leave it in exponential form. The next one is the product, the power to a product. So again, this exponent is going to go on every single term here. And notice it's also got exponents here, so we're going to have to multiply. So here, we're going to 3 to the 4th power, raised to the 3rd power, power to the power, we're going to multiply, and this becomes 3 to the 12th. For the x squared, raised to the 3rd power, again, multiply those exponents. The next one is applying the quotient to a power. So again, this 3rd power that's out here is going to go on the 2, and it's going to go to the b. So 5 times 3 becomes 2 to the 15th. B to the 4th, raised to the 3rd power, will become b to the 12th. Again, remember, the denominator, the value of b, cannot be a 0. If it is, then this problem is undefined. The next example is actually a combination of both the product to a power and a quotient to a power. So it's like a combination here. Okay, so the first thing we can do is we could take this 5, this exponent or this power, and we could separate. And we could give it the numerator, the power of 5, and the denominator, the power of 5. Now we can apply that product property, and we can put the 5 on the 2, on the m to the 6, and put on the t and the z. So here, -2 to the 5th, m to the 6 to the 5th, t squared to the 5th, z. Now notice this didn't have an exponent, so I assume there's a 1 there. And now I can start multiplying and figuring out what all these are. So -2 to the 5th power, that's going to be -2 times -2 times -2 times -2 times -2, which will give me -32. I'm sorry? Okay, we can. Let's leave it in exponential form. All right, so we'll leave it as -2 to the 5th. And we're going to leave it in parentheses. And then we're going to raise m to the 6th to the 5th. So we're going to make this m to the 30th over t to the 10th, z to the 5th. Now, when we're using variables in Algebra 2, we're not going to just use x. We're going to use t's and s's and z's. Make sure you're writing clearly, because a lot of times when a student writes a z, sometimes they think it's a 2. Sometimes when they write an s, they think their handwriting is a 5. So make sure you're very, neat when you're writing. A lot of times with the z's, I'll put a little line through it, so I'll know that that's a z and not a 2. So just make sure you're writing nice and neatly. Okay, everybody good? Now, if they ask you to simplify or evaluate this more, we could have also simplified the -2 to the 5th and made it -32, m to the 30th, t to the 10th, z to the 5th. However, if we're leaving our answers, so if we're leaving it in exponential form, this is our answer. Okay, next we're going to talk about anything raised to the 0 power. This is something you're going to memorize, that anything to the 0 power equals 1. Now, you do need to be careful when you're raising a negative integer to a 0 power. If there's parentheses around that negative integer, the answer is 1. If there's not a parentheses around it, the answer is -1. So, for example, if I said, what is 10 to the 0 power? You're going to tell me 1. What's 1 million to the 0 power? 1. Okay? So, anything to the 0 power is 1. Now, if I have a -10 and it's in parentheses, what I'm doing here is raising that whole -10 to the 0 power, and my answer is 1. However, if I do not have parentheses around the -10, then what this power is, this 0 power is only on the 10. So I would evaluate 10 to the 0 power. That would give me 1, but then this negative sign is going to fall down. Okay, so when there's no parentheses around a negative integer, the answer raised to the 0 power is going to be -1. So be careful with the negative integers. Okay, this is a tricky part of this. All right, let's try some examples. 4 to the 0 power, what do we get? 1. Now, we have -4, it's in a parentheses, so we're raising the whole thing to the 0 power, and this answer is 1. Now, this one, again, remember, the 0 power is only on the 4, so I would evaluate that as a 1, but then the negative sign is going to drop. So this would become a -1. So think of the parentheses as holding the negative sign together, and you raise that whole thing to the 0 power. But if it's not, it falls down and it goes in front of your 1. All right, let's try some more examples. Now, we don't have any 0 powers here, so now what we're going to be doing is multiplying two monomials here. So when we multiply monomials, we're going to multiply the coefficients, and then we're going to go through and look for the variables that are the same, and we're going to add those exponents. Now, notice on the x's, they don't have a power, so we're going to assume that they have a power of 1. So the first thing I'm going to do when I'm multiplying two monomials is I'm going to multiply the coefficients. So really what I'm doing here is -3, and I'm going to make it a fraction because I'm going to multiply it with a fraction. And the way that I can make a whole number into a fraction is I could put a 1 in the denominator. And then I'm going to multiply -3 over 1 times 1 over 5, and I get -3/5. Now I'm going to go back and I'm going to add my variable exponents. So I have an x to the first and an x to the first. So 1 plus 1 is 2. So I get x squared. And then I'll do the same thing with the y's. So y squared and y to the 4th, 2 plus 4, and I get y to the 6th. So my final answer is -3/5 x squared y to the 6th. So we're only adding the variable exponents when we're multiplying. Now, in Algebra 2, we love fractions. Fractions are friends, so you're going to see a lot of problems with fractions. So make sure that you're comfortable with working with fractions. Let's try the next one. So again, I have two monomials, and again, I'm going to multiply the coefficients. So I'm going to multiply 2/3 times 1/3. Now, when possible, I always look to see if I can simplify before I multiply. I can't simplify anything here, so I'm going to multiply the numerators and the denominators, and I get 2/9. Now I'll go back, look for my like variables. Again, this x needs an assumed 1, so 3 plus 1, and I get x to the 4th. I'll go back, look at my y's, assume a 1 on that one, 1 plus 2, y to the 3rd. So final answer, 2/9 x to the 4th, y to the 3rd. Pretty good? All right, let's try adding and subtracting polynomials. So polynomials are added by adding coefficients of like terms. Polynomials are subtracted by subtracting the coefficients of like terms. When we add and subtract polynomials, we're not doing anything with the exponents. All we're doing is adding and subtracting the coefficients, so the numbers in front of the variables. So let's go ahead and look at our first example. So essentially all we're doing here is combining like terms. So let's go ahead, and I've got my iPad here, and I'm going to color code my like terms. So I'm going to look for all of the y to the fourths, and I can combine those two, and I'm only going to add the coefficients. So 2 plus 4 gives me 6, y to the fourth. When I'm adding polynomials, I do not add exponents. I only add exponents when I multiply. Then the next one, I'm going to look for all my y squareds. And again, you're going to pull the sign in front. So this is a negative 3y squared plus 7y squared, which will give me positive 4y squared. And then lastly, I'll look for all of my y terms. Again, remember, if it doesn't have a number in front, you assume it's got a 1. So 1y plus 6y. And I get 7y. Now, notice I wrote my answer from the greatest exponent to the least. This is standard form. So you should always write your answers in standard form from the largest exponent down to the smallest. If this problem had a constant, I would also put the constant as the last term. My next problem is a subtraction problem. Now, when I do subtraction of polynomials, I do something I call keep, change, flip, or state, change, change. Sort of like what you did when you added and subtracted integers. Because the biggest difficulty I find is when students go to subtract, they remember to subtract the first term, but then they forget about anything behind it. So what I always do is I keep my first polynomial the same. So I'm going to leave this one alone. I'm going to change the sign in the middle to a plus sign. And then I'm going to take all of the signs in that second polynomial and make them opposite. And now I'm going to treat this as an addition problem and combine my like terms. Another way you could treat this problem is think of this subtraction sign here as a -1 that you're distributing to each of the terms. So now that I've changed the signs and I've made this an addition problem, I'm going to look for my like terms or my like variables. So I can add my m to the third powers. And again, I can assume a little 1 here in front of this m to the third. So -3 plus -1 is going to give me -4 m to the third. Underline that in red. Then the next like terms I'm going to look for are my m squareds. So a -8m squared plus a -7m squared. And I get -15m squared. Notice the variable exponents are staying the same. I'm just adding and subtracting coefficients. And then lastly, the constant, 4 plus 3, and I get 7. And again, my answer ended up in standard form. Good? All right. Let's try 2 more examples. And we're finished. Okay, so again, it's already set up. It's an addition problem. I'm just looking for like terms. So notice I have an MP, 8MP, and notice the exponents are the same. So these are like terms. So I'm just adding the coefficients. So 8 plus 11 gives me 19. M to the fourth, P to the fifth. The next like term I have is that M cubed P to the fifth. So I'm going to add -9 plus 15, and I get positive 6, M to the third, P to the fifth. And I'm done. Now, the next one's a little bit more complicated. Notice there are some constants outside of my polynomials. I need to distribute that 4 into the first polynomial, and then I need to distribute, and I'm going to treat this as a -5 that I'm going to distribute. So I'll go ahead and do the first one. I'm going to simplify by distributing a 4 to the x, to the -3, and to the 7. So this becomes 4x squared minus 12x plus 28. And again, I'm going to treat this as a -5 that I'm going to distribute to these 3 terms. So -5 times 2x squared gives me -10x squared. -5 times -8x gives me positive 40x. And lastly, -5 times -4, negative and a negative is a positive. Now that I've distributed, now I need to go back and add my like terms. So again, I've got some x squared terms that I can combine. So 4 minus 10, or 4 plus -10, however you want to think of it, is -6x squared. Then I'm going to add my x terms. So -12 plus 40 gives me positive 28x. And lastly, the constants, positive 28 plus 20 gives me 48. And again, my answer is in standard form. It's from the largest exponent down to the constant. It's like a countdown. Any questions? Okay, so on the last page here of the slide, and it's also in the assignment, you have homework on from pages 32 to 33. You're doing 5 through 13 odd, 29 through 33 odd. Again, show me work if it's appropriate. Again, check your answers. If you're getting them wrong, you can ask me. We have quite a bit of time here. And again, if you have any questions about any procedures or anything that you should be doing in class. Any questions?